This is example 12-1, wave speed in a channel. So the idea is that we have this channel here, water is flowing from left to right, more or less, and we throw a stone in it, and of course the stone is going to create a circular wave, and part of that wave is going to go upstream, and part of it is going to go downstream. If we are a stationary observer, right, we're the one who threw the stone, then of course we will see them moving in different velocities, right? Because the ring, as it's kind of expanding out, is going to be transported down the channel, right? So part of it is going to move faster, other parts are going to move slower. And we're now asked to figure out how fast the wave travels upstream and downstream, and also what the Froude number is. To do that, we'll start with the wave celerity. So we'll say C. So we're going to look at C. C is equal to gravity times the depth in my channel. Right? That's how fast my wave moves. And so we can say that is equal to 9.81 meters per second squared times the depth, 2 meter deep. So times 2 meters. That gives us meters squared over second squared, which is good because we get the velocity out of this. This gives us a velocity of 4.42944 meters per second. Right, so this would be if the water were not moving, we throw a stone in it, then the wave fronts would be moving up and downstream at 4.43 meters per second. So now if we want to see how fast it's moving downstream, we can just take that and add 1.5 meters to it, right? So we can say velocity down would then be 4.42944 meters per second, plus it's moving at 1.5 meters. That gives us 5.93 meters per second. Of course, this would be meters per second too. Right, so this would be from us as a stationary observer. Right, we're adding the velocity of how the water moves plus how fast the wave moves. Right, so that would be the one going downstream. Upstream is the same. We just need to subtract. So V up would then be 4.42944 meters per second minus 1.5 meters per second, and that gives us 2.93 meters per second. All right, so that's the two velocities that we get. And we're also asked to find out what the Froude number is. Let's underline this here. All right, so we can say the Froude number is equal to the flow velocity over the wave celerity, 1.5 meters per second divided by 4.42944 meters per second, 0.3386, which is less than 1, which means we have subcritical flow. That's our Froude number right there. All right, and that fits to what our solution was, right? Because we get a velocity going downward and a velocity coming upward. If we were at critical velocity, right, then that would mean that the water in the stream is moving just as fast downstream as the wave is expanding. So we would get downstream, we just get 2 times the critical, and upstream we'd have 0. If we're in supercritical, right, then our waves don't expand upwards at all. Everything just moves downward. All right, but this was looking at the wave of a stone that we throw into this kind of very simple channel, and we found that we are at subcritical flow.